If you've ever jumped into Kubernetes, you know networking can feel, well, like a giant tangled mess, right? All these IPs, ports, and policies. But what if I told you it's all built on just a few simple, really powerful rules? In this explainer, we're going to untangle all that complexity and show you exactly how it all works together, piece by piece. Welcome to CloudNet Explains Kubernetes series. We're kicking things off with the absolute foundation, networking. I mean, before we can get into the cool stuff like deployments and stateful sets, we've got to understand how everything talks to each other. And hey, don't forget, all the notes and links for this explainer are down in the description below for you.
So, you've probably heard these terms thrown around. Pod IP, Node IP, Service IP. They're basically the three core addresses in any cluster. And today, we're going to break down exactly what each one is, what it's for, and most importantly, how they all fit together to build an application that doesn't fall over.
All right, here's our game plan. We'll start with the fundamentals, the IPs and the machines. Then we'll dive into the core rules that make Kubernetes networking even possible, and the plugin system that does all the heavy lifting. After that, we'll look at the central problem this whole system is really designed to solve. From there, we'll introduce the hero of our story, the service, and show you how to expose your apps. And finally, we'll bring it all home with a real-world example. First up, let's lay the foundation. Before we can get how things communicate, we need a crystal clear picture of what those things actually are. And it all starts with two fundamental pieces. Let's start with the easy one, the node IP. A node is just a server in your cluster. Could be a physical machine, could be a VM in the cloud. Each one of these nodes gets a stable, predictable IP address on your main network. Think of it like the street address for the machine itself. It's the physical foundation, and it doesn't change.
Okay, now here's where it gets interesting. A pod is the smallest thing you can deploy in Kubernetes. It's the little bubble where your application's containers actually live, and every single pod gets its own unique IP address. This is awesome, because containers can communicate without fighting over ports. But, and this is a huge but, this IP address is ephemeral. That's a fancy word for temporary.
So let's lock this in, because it's super important. Node IPs are stable, they live on your main infrastructure network, and they're for the machines themselves. Pod IPs are temporary. They live inside the cluster's private network, and they're for your applications. Getting this difference is absolutely key to understanding everything else that follows. Now that we know about nodes and pods, let's peel back the curtain and see how the magic actually happens. This is all about the golden rules and a little something called CNI.
Believe it or not, the entire Kubernetes networking model, with all its complexity, is built on just three core principles. That's it. Everything else is just about making sure these three simple rules are always true. So here they are, the three golden rules. 1. Every pod can talk to every other pod directly. No complicated network address translation, or NAT. 2. Every node can talk to every pod. Again, no NAT. And 3. A pod sees itself with the same IP that everything else sees it with. What this creates is a simple, flat network where everything can find everything else. It's clean.
So how does Kubernetes enforce these rules? Well, here's the secret. It doesn't. Instead, Kubernetes uses a standard called CNI, the Container Network Interface. Think of CNI as a contract that lets specialized network plugins like Calico, Flannel, or Cilium do all the dirty work of assigning IPs and setting up routes. This makes Kubernetes incredibly flexible. Okay, so we've got this beautiful, flat network where everything can talk to everything. Sounds perfect, right? So what's the problem? Well, this perfect system has a built-in weakness, and that brings us to the core challenge, the problem with pods.
The problem, in 2 words, is that pods are temporary. They are designed to be ephemeral, disposable, and replaceable. Now, this is actually a huge strength for building resilient apps, but for networking, it creates a massive headache.
And here is the direct consequence of that design. Every single time a pod crashes, or gets rescheduled, or you deploy a new version, the old one is destroyed and a new one is created. And that new pod, it gets a brand new, completely different IP address.
This is why you should never, ever, ever rely on a pod's IP address directly. If your front-end code tries to connect to a back-end using its specific pod IP, your application is absolutely guaranteed to break. It's not a matter of if, but when.
So how do we solve this? How do we talk to something whose address is always changing? Well, say hello to the hero of our story, the Kubernetes service. It's a simple abstraction that provides a stable, reliable endpoint, solving this whole ephemeral IP problem once and for all. Think of a service like a permanent PO box for your pods. It gives you a stable virtual IP and a consistent DNS name that never change, even while the pods behind it are constantly being created and destroyed. It automatically finds the right pods and load balances traffic between them, decoupling your application so it just works.
So how does a service know which pods to send traffic to? It uses this wonderfully simple system called labels and selectors. First, you put a label, basically just a tag, on your pods, like app backend. Then you create a service and tell its selector to look for that app backend label. The service then just constantly watches for any pods with that tag and keeps its list of targets up to date automatically. It's a self-healing system.
Okay, now that we know what a service is and how it finds its pods, let's look at the different types you have in your toolkit. This is how you expose your applications, both inside the cluster and to the big wide world.
You've basically got three main flavors. First is cluster IP. This is the default, and it creates an IP that's only reachable from inside the cluster, perfect for your backends and databases. Then you have node port. This exposes your app on a static port on every node's IP. It's super handy for quick development or testing. And finally, the big one, load balancer. In a cloud environment, this automatically spins up an external cloud load balancer, giving you a public IP for real user traffic.
Let's quickly trace the path for a node port, since it shows how all these pieces connect. An external user sends traffic to the IP of any node on that special node port. That node grabs the traffic and forwards it to the internal service IP. Then the service does its job, picks a healthy pod, and sends the traffic to the right container port on that pod. See how it all connects?
All right, we've covered all the core concepts, from pod IPs all the way to service types. Let's put it all together now and see how these pieces work in harmony in a real-world app. Okay, picture a simple web app, front-end, back-end, and a Redis cache. The front-end pods, they don't know or care about the individual back-end pod IPs. They just talk to the stable DNS name for the back-end service, which is a cluster IP service. That service routes the traffic to a healthy back-end pod. Same thing for the back-end. It talks to the Redis cache through another cluster IP service. No component ever needs to know the direct changing IP of another. It makes everything way more resilient.
So if you take away nothing else, please remember these four things. 1. Pod IPs are temporary. Don't trust them. 2. Services are the solution. They give you a stable address. 3. Labels and selectors are the glue that connects services to pods. And 4. Choose the right tool for the job. Cluster IP for internal stuff, node port for dev, and load balancer for production.
And that's our whirlwind tour of Kubernetes networking. I really hope this helped clear things up. If it did, and you want to keep diving deep into how all this cloud-native tech works, please be sure to subscribe to Cloud Nate Explained. Thanks so much for watching.